In this video, we're going to finish up our mutually exclusive events worksheet on the KutaSoftware website under the geometry section. For this next set of problems, we're going to determine if events A and B are mutually exclusive. If they are, remember that intersection is equal to 0. Therefore, P of A, the probability of A, plus P of B, the probability of B, will equal the probability of A or B, the probability of A union B. So looking at number 9, we're going to see if 3/10 plus 1/2, does that equal 4/5? Well, in order to add fractions, I need a common denominator. So I'm going to multiply 1 by 5 and 2 by 5, simply multiplying by 1. So I'm not changing the value of 1/2, but I'm putting it in terms of 10 in the denominator. So I'll have 3/10 plus 5/10. Does that equal 4/5? 3/10 plus 5/10 is 8/10. And 8/10 when simplified does equal 4/5 because 8 divided by 2 is 4 and 10 divided by 2 is 5. Therefore, in number 9, events A and B are mutually exclusive. In number 10, the probability of A, 7/20, plus the probability of B, 11/20, does that equal the probability of A union B of 283 over 400? 7 plus 11, since I have the same denominator, I can just add the numerators. That will give me 18 over 20. Now, does that equal 283 over 400? In order to go from 20, I would multiply by 20. So I'll multiply the top and the bottom both by 20. So that'll give me some fraction out of 400. So I can see if that numerator is the same, 283. 18 times 20 equals 360. And because 360 out of 400 does not equal 283 out of 400, then these events, A and B, are not mutually exclusive. Now remember, for mutually exclusive events, the probability of A and B has to equal 0. However, we're given that the probability of A and B is equal to 21 out of 400. That does not equal 0, therefore events A and B are not mutually exclusive. In number 12, it tells us that the probability of A and B equals 0. Therefore, right away we can say that events A and B are indeed mutually exclusive. In number 13, they give us the probability of A, the probability of B, and they also give us the probability of A given B. Now remember, the probability of A given B equals the probability of A intersection B divided by the probability of B. So if I multiply both sides by the probability of B, I can say that the probability of A given B times the probability of B equals the probability of A intersection B. So if the probability of A given B times the probability of B, if that equals 0, then the events will be mutually exclusive. If it does not equal 0, then they will not be mutually exclusive. So the probability of A given B is 33 over 50, and the probability of B is 1/2. 33 times 1 is 33, and 50 times 2 is 100. 33 out of 100 does not equal 0. Therefore, in number 13, because the probability of A intersection B does not equal 0, then the events are not mutually exclusive. In number 14, it gives us the probability of A, the probability of B, and the probability of A given B. So the probability of A given B equals the probability of A intersection B divided by the probability of B. So again, if I multiply both sides by B, I'll get that the probability of A given B times the probability of B equals the probability of A intersection B. So if these are mutually exclusive, then that intersection will be equal to 0. And the probability of A given B is 0. And 0 times any number, 11/20 in this case, is equal to 0. So because the intersection of those events is 0, then these events are mutually exclusive. In number 15 and 16, it states that A and B are mutually exclusive. So we're to find the missing probability. Remember, if A and B are mutually exclusive, then the probability of A or B is going to be equal to the probability of A plus the probability of B, because the probability of A intersection B equals 0. The probability of A and B is 0. So in number 1, we're looking for A or B, so we'll simply add. The probability of A or B, A union B, equals the probability of A 1/4 plus the probability of B 13/20. Now, I need to add these, but in order to do so, I need a common denominator. If I multiply 1/4 by 5 over 5, I'll get 5/20 plus 13/20. And again, that was multiplying 1 by 5 and 4 by 5, which is simply multiplying by 1. 5 plus 13 is 18, and that's over 20, which we can simplify since both are even. 9 times 2 is 18, and 10 times 2 is 20. So 9/10 is our solution in number 15. In number 16, the probability of A is 2/5, the probability of B is 1/4, and it asks what the probability of A and B is. However, if they're mutually exclusive, we know that the probability of A and B, that intersection, must be 0 because we're told that they're mutually exclusive. Therefore, 0 is the answer in number 16. And the last set of directions, we're going to be finding the missing probability. So we're not told whether they're mutually exclusive or not. Now, before I jump into this, go ahead, click that like button, and while you're at it, click that subscribe button as well. Now, on to number 17. Number 17 says that the probability of A is 7/20, and the probability of B is also 7/20, and the probability of A union B equals 49 out of 80. So we're finding the probability of A and B. Well, regardless of whether the events are mutually exclusive or not, the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. Now, if they're mutually exclusive, we know that this is 0, so we could just use this formula. But because we don't know whether they're mutually exclusive or not, we need to keep that probability of A intersection B in there because that's what we're solving for. So the probability of A union B is 49 over 80. The probability of A is 7/20. The probability of B is also 7/20, and we're looking for the probability of A intersection B. So we'll have 49 over 80 equal to the probability of A plus the probability of B, 7/20 plus 7/20, which I can add to get 14/20 because they were over the same denominator. Then we have to subtract the probability of A intersection B. Now, in order to solve, I need to subtract 14/20 from both sides. However, I want the denominator to be 80. So as opposed to subtracting 14/20 from both sides, I'm going to subtract 14 times 4 over 20 times 4. So I'll be subtracting 14 times 4, which is 56, over 20 times 4, which will give me 80. I'll have 49 over 80 minus 56 over 80. That will equal the opposite, or negative, of the probability of A and B. 49 minus 56 equals negative 7. So I have negative 7 out of 80 equal to the opposite of the probability of A intersection B. So what am I going to do? I'm going to multiply both sides by negative 1 because I don't want that negative probability, I want the positive probability. So 7/80 equals the probability of A intersection B. And now I know, since the probability of A intersection B was not 0, then the events were not mutually exclusive. In number 18, I'm solving for the probability of not B. But first, I need to figure out what the probability of B is in order to solve. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So the probability of B is what I'm trying to solve for in order to solve for the probability of not B. So I'll plug in the probability of A union B, A or B, of 283 out of 400. That's equal to the probability of A, 11/20, plus the probability of B, minus the probability of A and B, which is 77 out of 400. I'll start by adding 77 out of 400 to both sides. So 283 plus 77 equals 360, and that's out of 400. That's going to be equal to 11/20 plus the probability of B. Next, I'm going to subtract 11/20 from both sides. Now, I know that I can simplify this fraction so that it has a denominator of 20. So I'm going to rewrite 360 out of 400 as not 36 out of 40, but dividing both the numerator and denominator by 2 as 18 out of 20. So I'll have, continuing my work, I'll have 18/20 minus 11/20 equal to the probability of B. 18 minus 11, that'll be 7/20 equal to the probability of B. But I'm looking for the probability of not B, so the probability of not B equals 1 minus the probability of B, which is 1 minus 7/20, so that will leave me with 13/20 for number 18. And that wraps up this worksheet. If you have any questions, leave them in the comments below. And if you haven't done so already, like, subscribe, and share.